All right, welcome. So today, we're going to pull back the curtain on something that's, absolutely fundamental to video games: interactivity. We're going to get into the nitty-gritty of the simple but super powerful logic that lets a game react to you, speeding you up, slowing you down, and just making the whole world feel, well, alive. Okay, let's get into it.
Have you ever really thought about it? You drive your little car over some glowing arrows on the track and bam, you're suddenly blasting forward. Or you clip a wall and you grind to a halt. It all feels so natural, right? But underneath that feeling is a set of really clear, logical rules. And today, we're not just going to talk about those rules, we're going to build them right here, together.
So to really get how we build dynamic gameplay, let's start with the complete opposite. Just picture a super simple driving game. You press the W key, your car moves forward, and that's it. It never gets faster, it never gets slower, it just goes. How boring would that be? You probably quit after about 30 seconds, right? The world feels totally static, completely unresponsive. It's not really a game, it's more like a car stuck on a conveyor belt.
So that right there is our core problem. We've got the basics of a game, but it's missing that key ingredient of interaction. How do we take this, totally flat, one-note experience and start adding in the peaks and valleys that actually make a game fun and challenging? Well, the answer lies in giving our game a way to remember things, and more importantly, a way to change things.
This number, 20, this is the entire heart of our boring static game. In the code, this number is tucked away inside something called a variable. Now, if you're new to this, a variable is just a container in the game's memory. Think of it like a labeled box. You give the box a name, in our case we'll call it move speed, and then you put something inside it, like the number 20. So anytime the game needs to figure out how fast the car should be moving, it just finds the box labeled move speed, looks inside, and pulls out that number. And right now, it's always 20.
So to fix our boring game, we need more options. We can't just have one box with one number in it. We need a whole dashboard of speed dials that we can crank up or down whenever we want. And in the world of programming, that just means we need to create more variables. We're going to create a couple of new boxes, new containers, for different speed scenarios. This is what's going to give us the power to change the car's state on the fly.
Okay, now this is where it gets interesting. This table basically lays out our entire game plan. If we were to peek inside the C# script that's controlling our car, we'd see these variables defined right at the very top. It would look something like this. Public float move speed equals 20f. Then on the next line, public float slow speed equals 15f. And finally, public float boost speed equals 30f. Let's break that down real quick. The word public just means we can see and even change this value in the Unity editor without having to dig back into the code. Float is just a fancy programmer word for a number that can have decimal points. And that little f you see at the end of the numbers, that's just how we tell the C# language, hey, just so you know, this is a float. Now, the most important part to get here is that even though we now have 3 different speed options, the part of the code that's actually pushing the car forward is only ever looking at one thing, the current value of move speed. So our job as the game developer is to write the rules that swap out what's inside that move speed box when cool things happen in the game.
All right, let's build our first interactive event, the speed boost. So for this to work, we need a way for the game to know when our car is driven over that boost pad. We don't want the car to physically crash into the boost pad. That would be weird. We want it to pass right through it, and in doing so, activate an effect. And for that very specific job, we have a special tool called a trigger.
A trigger is pretty much exactly what it sounds like. It's an invisible zone, an invisible boundary in your game world that's just sitting there, constantly waiting for something to enter it. The best analogy is one of those automatic toll booths on the highway. Your car drives through the sensor zone, the sensor says, yep, got one, and an event happens. Maybe a gate lifts or your account gets charged. But you never physically hit the sensor, right? You just pass through its zone. That is a trigger, a non-physical event zone that detects presence without causing a crash.
So let's imagine we're building this in a game engine like Unity right now. First, we'd create our boost pad object. This could be anything, a simple cylinder that we squish down to look like a pad on the road. But right now, it's just a pretty picture. It doesn't do anything. To give it a presence in the game world, we need to add a collider component. So, with our pad selected, we'd go over to the inspector window, click Add Component, and we'd search for something like a box collider or sphere collider. This draws an invisible shape around our pad that the physics engine can now recognize. But, and this is the most important step, on that new collider component, there's a little checkbox that says Is Trigger. We have to check that box. That one single click tells Unity, hey, don't treat this like a wall. Don't make things crash into it. Just let me know when something enters its zone. And finally, to make it super easy for our code to know what we've hit, we're going to give it a tag. At the very top of the inspector, there's a tag dropdown. We can add a new tag, name it Boost, and then assign that tag to our boost pad. Perfect! Our trap is now set, and we're ready to write the code that waits for it to spring.
And this right here is the little piece of code that makes all the magic happen. Inside our car's main script, we use a special built-in Unity function. It's called onTriggerEnter. This function is like a dedicated watchman. It just sits there, and it automatically runs the very instant our car's collider enters any trigger zone. Inside this function, we write a really simple if statement. We ask the question, if other.compareTag boost. Okay, let's unpack that. The word other is a placeholder for whatever we just ran into. In this case, it's our boost pad's collider. The .compareTag part is just a very clean and efficient way of asking, hey, the thing I just drove into, does it happen to have the tag boost? If the answer is yes, then the code inside the curly braces runs. Move speed equals boost speed. It's that simple. We're literally just taking the value from our boost speed variable, which was 30, and we're putting it into the move speed variable. Immediately, the code that moves our car starts using that new higher number. And just like that, we are boosting.
But you know, coding is always a process of trial and error. And here is a perfect example of a little mistake, a little gotcha that trips up almost everyone when they're starting out. See, when a trigger event happens, the code gets information about both objects, itself, which is the car, and the other object, which is the boost pad. A beginner might accidentally write code that just checks for tag. And what that does is ask, what is my own tag? Well, the car's tag isn't boost, so the condition is false and nothing happens. You have to use other.tag to specifically ask, what is the tag of the other thing I just overlapped with? It's a tiny, tiny difference in the code, but it makes all the difference in the world, and it really shows you how precise you have to be when you're writing game logic.
And I absolutely love this point from the source material. Seeing these little mistakes, and more importantly, seeing the process of figuring them out and fixing them is so valuable. It totally demystifies what it means to be a developer. It's not about writing flawless, perfect code on your first try. Nobody does that. It's about having an idea, forming a hypothesis, testing it, and then figuring out why it didn't work and fixing it. Every single developer, from a brand new beginner to a seasoned expert, goes through that exact same loop of debugging. It is the heart of making things.
Okay, so we've successfully used a trigger to speed our car up. That's our boost. Now it's time to build the bump. What happens when we smack into a wall or another object? Well, for this, we definitely don't want to just pass through it. We want a real physical reaction. And for that, we need to use the cousin of the trigger, the collider.
So if a trigger is like an invisible sensor, a collider is like a brick wall. It's the component you add to an object that gives it a solid physical shape in the game world. When two objects with colliders meet and neither one of them is marked as a trigger, the physics engine kicks in and creates a collision. They'll bounce off each other, they'll stop, they'll transfer force. A collider's entire job is to answer one simple question: did something physically hit me?
Yeah, this slide just lays out the difference perfectly. The code for our boost used a function called onTriggerEnter, which, as we saw, fires when you pass through a non-physical zone. For our bump, we're going to use a different but similarly named function, onCollisionEnter. This one only runs when our car's collider has a real physical impact with another solid collider, like smashing into a wall. One is for detection without contact, the other is for physical interaction. They're both essential tools, but you have to know which one to pick for the job.
And you know what's great? The code for this is even simpler than our trigger code. Back in our car script, we just add another one of these built-in Unity functions, onCollisionEnter. This function will run automatically the instant our car physically smacks into any other solid object that isn't set to be a trigger. And inside it, we only need one single line: move speed equals slow speed. That's it. We don't even need an if statement to check a tag this time, because our design says we slow down when we hit anything. The moment that physical collision happens, boom, our move speed is immediately set to our slow speed variable, that 15 value, and the car lurches to a crawl. It's simple, it's elegant, and it's incredibly effective.
So let's just take a quick step back and look at what we've done. With just 3 variables and 2 super simple built-in functions, one for triggers, one for collisions, we have completely revolutionized our game. We went from this boring one-speed world to a dynamic, interactive environment where the player's actions have immediate, clear consequences. Hitting a boost feels awesome and rewarding. Crashing feels like a real penalty. The world is finally talking back to us.
So what are the big things to take away from all this?
First, variables are your foundation. They act as the game's short-term memory, holding different states like slow speed, normal speed, and boost speed. Second, you have two main tools for detecting what's going on. Triggers for those non-physical events like power-ups, which you listen for with on-trigger enter, and colliders for the hard physical impacts, which you listen for with on-collision enter. And finally, the real magic happens when a few simple lines of code, like an if statement or a basic assignment, connect these systems together, swapping the values in your variables to change how the game feels in real time. That combination is the secret sauce that creates the fun in so many games.
And really, this is the most exciting part, because this logic goes way beyond just speed boosts. A trigger could be the zone that starts a conversation when you walk up to a character. It could be an invisible area that opens a secret door when you enter it, or plays a spooky sound effect, or even changes the background music. A collision could be what damages a player, or breaks a crate, or launches a pinball off a bumper. The concepts we just used are exactly the same. So the real question is, now that you know these fundamental building blocks, what kind of interactive world would you want to create?